Hi everyone, welcome back to my channel. And firstly, sorry to all those who are waiting for my videos recently. And due to my daughter's half saree function, I couldn't upload videos regularly from the past 20 days. Yes, sorry for that. And yeah, I'm back with the videos. From today onwards, I'll be resuming my videos continuously on VLSI like Verilog, System Verilog, UVM and all. And in today's video, apart from all these things, recently from past 20 days, I'm receiving continuously from many of the students who are studying in ECE and Triple E also. Like many of them are asking, like some third and fourth year students are asking that what are the important concepts in digital electronics that we need to prefer while we are entering into any VLSI core company interviews and all. So, keeping this in my mind, I try to make a video on this particular concept, right? So that it will be useful for all those third and final year students to brush up their digital electronics concepts. Which why? Because if you want to enter into VLSA domain, one of the most important topic that you need to concentrate is digital electronics, which you encounter in your third and final years. Like we will be having this DSD, right? Digital electronics. So all of the subject is same. So in these subjects, what are the things that you need to concentrate on if you are entering into any company related to VLSI core, right? So, and before getting into today's video, if you are new to this channel, please consider subscribing my channel and hit on the notification bell also. And also do follow me on LinkedIn, and you can join my Telegram channel to get the courseware related to design and verification domain courses like Verilog, System Verilog and UVM. Yes, so coming to today's topic, which is important concepts in digital electronics that you need to concentrate on if you are attending any interviews related to VLSI domain, right? So the first concept is the weighted and non-weighted code. So this is the basic concept. Okay, like you will see the binary codes, gray codes, and the conversion between the binary code and gray code. So these may seem as basics, but you need to concentrate mainly on this topic first thing. Okay, so the first important concept is weighted and non-weighted code and the conversions of binary to gray and gray to binary, right? So and also some complementing and cyclic codes also you need to concentrate on. So this is the first important concept. And then coming to the second important concept, you need to know what is the importance of one's complement and two's complement. Okay, so you need to know about the ones complement and two's complement, and also you need to have a error detecting and error correcting code information also. Like you need to have concentrate on these two things also, error detecting and error correcting of codes, right? And then after this, you need to know the most important concept, which is k maps. So basically, in order to know the reduction of these k maps and all, you need to know the De Morgan consensus theorem, right? So first you need to have the knowledge on what is De Morgan's theorem and what is consensus theorem, and then the tabulation of k maps, like how to reduce the code for the k maps and all. You need to understand that, right? So this is the third important concept in digital electronics. Next, the most, so these three are considered as the basics. Like first you need to know what is weighted and non-weighted codes, and then you need to know the conversions of binary to gray and gray to binary, and then one's complement and two's complements, and then the k-map reduction, right? So these are the four basic things that you will be studying in the basic digital electronics concepts. Now coming to in-depth concepts in digital electronics, the first important thing in digital electronics is that it is divided into like two categories. One is combinational circuits and the sequential circuits. So firstly you should understand what is combinational circuit and what is sequential circuit, and what is the difference between combinational circuit and sequential circuit, right? And then what circuits come under the combinational circuits and what circuits come under the sequential circuits. Like what is the difference between this combinational and sequential circuit? You should understand that. And then within the combinational circuits, you are having lots of combinational circuits like adders, subtractors, multiplexers, right, encoders, counters, so all these things. So basically, so you need to understand all these concepts. So you need to know the reduction, not understanding. You need to know how to reduce the thing. Basically, when you come to this combinational circuits, how you were asked in the interview is like this particular questions. If you see here, implement 4 by 1 mux using 2 by 1 mux without using any additional gates. So without using any additional gate, you need to know how to implement a 4 by 1 mux using 2 by 1 muxes, so that if you know how to implement it, then you can just convert it into a code, right? So these implementations are in this manner. Like you need to know how to build a bigger muxes or bigger adders. For example, if you say design a 16 by 1 mux using 2 by 1 mux, so this is basic simple question. Okay, some will be asking like you have to design a 15 by 1 mux. Okay, in this way there are various types of questions. So for this you need to understand what is mux and how to reduce, what are the things that we can use in order to use this implementation. So all these things will come by practice. Okay, so it is not done in one day. You day by day, if you go on practicing all these things, then you can definitely reach a point where you can definitely write your own code and implement it. Right, so this is the basic combinational circuits that you need to understand. And then coming to decoders, similarly, just like muxes, decoders also, you are asked to implement some decoder using some other basic decoders, like, so this is the thing. In the similar way, you will be asked to design adders. Okay, so if you see here different types of adder circuits, like you are asked to design a full adder using some half adders. Similarly, you are asked to design some full ladder circuit using some small adder circuits. In this way you are asked to design some adder circuits, right? And then coming to the sequential circuits. Okay, as I told you, you have to know what is the difference between combinational and sequential circuit. And within sequential circuit, the most important concept in sequential circuits is flip flops and latches. So you need to know what is the difference between latch and flip flop. Again, after knowing what is the difference between latches and flip flops, you need to know what are different types of flip flops that we use. Like we are having various kinds of flip flops like JK flip flop, SR flip flop, T flip flop, D flip flop, everything. And then after knowing what are the kinds of flip flops, you need to know how to convert one flip flop to another flip flop. Like how to convert JK to SR, similarly T to D, D to T. In this way, how to convert one flip flop to another flip flop, right? And then after this you need to know about the counters, like how to implement a counter. You're having various kinds of counters like Johnson counter, ring counter, ripple counter, up down counter, right? You need to know how the implementation of all these counters is happening, like mod counter with specific duty cycle implementation. So you need to know these various kinds of counters in digital electronics, right? So these are very important concepts within the digital electronics counters concept, right? Then coming to after this, like if you see here, until here you have seen all the combinational and sequential circuits. Like you will be seeing adders and then mux and then what encoders, decoders. So all these things you will be learning in digital electronics. Then comes the sequential circuit. So within the sequential circuit you will be learning about flip flops and then counters, so all these things, right? And then after this, the actual implementation of the things that you have learned. So actually the sequence detectors. Okay. You will be having the FSMs, which are finite state machines, right? So again, within FSMs you are having various kinds like Mealy and Murray in order to reduce the FSM. Okay, so basically this FSM conversion will be done by using either overlapping method or non-overlapping method. I think you can understand what I am saying if you are related to, if you know about the digital electronics subject, right? So you will be writing a code for sequence detecting. Okay, I have explained clearly about this FSM in my particular one video. I link that in the description box. If you are someone who want to know how to write a code on FSM, please click on that particular link and you can check out that video so that you can understand how can we write a Verilog code for FSM, right? So this is about the sequence detecting. Okay, for example, you will be given a sequence and then you'll be reducing it by using overlapping and non-overlapping methods, either by using Mealy or Moore's finite state machines, and then you'll be writing a code for that particular sequence, right? So this is the thing. Now after this, what are the some other concepts that we will be seeing at the end of the these are after learning all the basic things, like we can say this is the most important concepts that we see in the real time applications. If you were asked for a digital electronics interview, so you may expect these types of questions, like how to design a circuit which operates at high frequencies. Okay, so basically, how are we going to design a circuit which will be operating at high frequency, and also how can we introduce a logic dynamically into that particular circuit. Okay, so this is how you will be asked a question, or else you will be asked to calculate the FIFO depth. Okay, you will be given some full and empty conditions, and based on that you are asked to calculate the FIFO depth. That means you were asked to write a code in order to calculate for FIFO depth. Or you will be asked what is the difference between synchronous and asynchronous FIFO. You need to know what is synchronous and asynchronous FIFO in order to calculate what this FIFO depth calculation and all. You need to know what is the difference between asynchronous and synchronous FIFO first, right? And then the other question that you can expect is what is the difference between I2C and SPI. If you know what is I2C and SPI, basically there are communication interfaces, like I2C is integrated circuit and SPI serial peripheral interface, right? So you were asked to know the difference between what is the difference between I2C and SPI, or on various arbitration concepts are clock synchronizations, clock stretching. So you need to know all these things related to that particular in digital electronics. And then the basic question or the most frequently asked question is BCD to 7 segment decoder. Okay, I think you already know about this, or any comparator circuits and all, right? So these are the various frequently asked questions in interview that you can expect when you are attending any VLSI core company relating to digital electronics. These are the concepts that you need to brush up, right? So hope this video is helpful for you. If you do like this video, please do give it a like and also share it to all the VLSI aspirants who also want to enter into design and verification domain, and who are preparing for VLSI core interviews, and who want to know the concepts in digital electronics, right? So hope you like this video. That is all for today. Thank you all.